Hello everyone, I hope you had a great trading week. I decided to prepare this presentation because I have noticed many of my followers have the same problem in trading, and that is making a mistake over and over again. To find the reason, we should first know how our brains work. Let's see on cartoons to understand what really is going on. My ultimate goal is to help traders make better decisions, and it is not possible without knowing how our brain works. Interestingly, we can be fooled by our brain because we don't know how it works. Sounds strange, but it's a reality. We think we know, but we are not aware of how our brain works. This presentation will help you to find out the importance of biological and psychological mechanisms involved in your decision-making process. Moreover, you will find out why you repeat the same mistakes again and again in trading, which leads to a vicious cycle of losing money in the market. Neil deGrasse Tyson said, "One of the great challenges in life is knowing enough to think you are right, but not enough to know you're wrong." Although I have followers with 35 years of trading experience, 68% of my followers are new traders with less than 1 year of experience. So they are dealing with lots of new information in trading without knowing how their brain processes new information. To understand how our brain processing new information, let's start with the first cartoon.
A schema is a generalization of past experiences that forms a scripted pattern of thought. For example, we all have a specific process in mind when we think about going to a restaurant. Some imagine standing in line, placing an order and eating, and then throwing the trash away. Others imagine being seated, then ordering, sharing everything, and then paying, leaving a generous tip. We can think of a schema as a mental framework in the form of a kid's toy. Things we already fully understand, say a triangle, get into our brain without a problem. When new information is similar to what we know, say a square, it can enter the brain through assimilation. For completely new information, here a star, this doesn't work. Then we need accommodation and to change the schema itself. Assimilation is the cognitive process of making new information fit in with your existing understanding of the world. It works if new information is close to what we already know. To process the new information, we make it fit into our existing schemas. We have to use accommodation if things are so unique that they don't fit into our existing schema. In other words, to understand something truly new, we first have to remodel our brain space. Just imagine you were born completely colorblind. Not a million books or the best teacher could ever truly explain red to you. You need to experience it to accommodate the idea. Frederick Bartlett demonstrated how schema unconsciously alter our perception and memory in what became known as the War of the Ghosts experiment. He did that by reading to his British students a strange Native American folktale from the Chinook tribe. The story involved ghosts, hunting seals, going to war, and canoeing. Later, he monitored how the students recalled what they remembered from the story, first days, then weeks, and then months after. 3 striking things happened. 1. Omission of unfamiliar details. Multiple students did not recall a part about the Chinooks going hunting seals. This happens because hunting seals does not naturally fit into the cultural context of rich British students. In other words, they do not have an existing schema for this kind of information. Therefore, they have a hard time understanding it and hence can't move it into their long-term memory for later recall, and so they forget. Bartlett argued that psychologically we conceive anything that doesn't fit our schema as irrelevant. 2. Familiarization of things strange. Some of the students that initially did remember the part about hunting seals later recalled the activity as going fishing. A canoe that was loaded with weapons was remembered as a rowboat. This happens because when we lack the words to describe new, unique experiences, we use idioms or figures of speech. In other words, we channel unfamiliar information through the framework of a familiar schema. And because we do that every time we recall that unique experience, over time it becomes more familiar and less authentic. 3. Rationalization of the illogical. Right after it was told, most students thought that the tale was strange. A few weeks later, however, it suddenly made a lot of sense to some of them. The students began to add terms such as therefore and because, and unconsciously made the story casual and logically coherent. Whenever they retrieved it from memory, they added a reason. The Chinooks didn't go hunting seals or to war on their canoes. They took the boats because they wanted to go fishing. Bartlett noted that each time the students were asked to recall the story, it had changed a bit, which means that long-term memories are neither fixed nor immutable, but are constantly being adjusted. This supports the existentialist view that people construct the past in a constant process of adjustment. In other words, much of what we remember is rationalized into a self-narrative that allows us to think of our life as a coherent string of events. Jean Piaget, who coined the term, argued that we construct our experiences into schemata so we can make sense of the world.
Now we know how our brain changes information by omission of unfamiliar details, familiarization of things strange, and rationalization of the illogical. Now we should proceed to the roots of our behavior. Robert Sapolsky theory. Robert Sapolsky's theory of behavior biology claims that behind every human action is a biological explanation. The concept centers around the idea that to truly understand human behavior, we must study at all levels, from what happens inside the brain a nanosecond before a behavior occurred to the time when humans and apes lost their common ancestor.
Sapolsky's theory of human behavioral biology claims that behind every behavior is a biological process that is the product of natural selection. If Sapolsky is right, this implies that to truly understand human behavior, we would have to know exactly what happens in the 100 trillion connections of the brain a nanosecond before the behavior occurs, and consider what took place about 5 million years ago when humans and chimpanzees shared their last common ancestor, and all the stuff that happened in between. For example, when we see someone who has done something wonderful and altruistic, or something brutal and savage, we can ask ourselves, why did he do that just now? And when we ask that, we are asking something about what neurons in different parts of their brain did a fraction of a second ago. But we are also asking about what environmental stimuli in the previous seconds to minutes triggered those neurons. And we are also asking, what did hormone levels in that morning have to do with making those neurons more or less sensitive to those triggers? And then we are often running into neuroplasticity, how his experience changed those neurons in previous months. Then you are back to adolescence and childhood and all the way back into his fetal life, which has a huge amount to do with what sort of brain we are going to have as adults. And even further back, genes come in, and culture, because the way you were raised within minutes of birth reflects the culture that your ancestors were coming up with centuries ago. And at the bottom of the barrel, why we evolved into this kind of species instead of that kind. If you trust Sapolsky's theory of behavioral biology, you may at this point realize that things are much more complicated. While a simple "she did A, so he did B" may fulfill your need to bring order into this chaotic world, it is likely not going to be the full explanation. Sapolsky was born in New York, and he spent his youth reading about and imagining living with silverback gorillas. By age 12, he was writing fan letters to primatologists, and during high school he taught himself Swahili. Later, he spent 25 years observing the same group of baboons in Africa every summer, and then went on to study and teach behavioral biology at Stanford University. Sapolsky left for those who try to understand others the following advice. We are complicated, so you better be really sure and really careful and really cautious before you decide you understand why somebody did something, especially if that is something you are judging harshly. It's like trying to judge how a movie got to its conclusion by only watching 30 seconds of it. What do you think? Is his theory solid, and can we actually never really explain a behavior without taking the full picture into consideration? Or is there something like a soul that takes decisions, regardless of what happens to us biologically?
Through Sapolsky's theory, we learned how complicated our behaviors could be. Now we should talk about habits and mechanisms that lead to repetitive behaviors. Before watching the next two cartoons, please ask yourself these questions. Why do I become so excited watching the monitor during market hours? Why do I become so sad, anxious, and depressed after losing trades? Why I cannot control myself from entering new trades?
Classical conditioning is a way of learning where a stimulus that triggers a biological response is paired with a new stimulus that then results in the same reaction. The most famous work in classical conditioning was done by Ivan Pavlov in the 1890s. During this time, Pavlov did a lot of research around the digestive processes of dogs. One day during his research, Pavlov noticed that the dogs began to salivate in the presence of the technician who normally fed them. He wondered if the technician was a trigger that stimulated a response associated with food. To find out, he constructed an experiment that would allow him to measure a dog's output of saliva. First, he served the dog food. Then, he served food while playing the sounds of a metronome and repeated the process a few times. Finally, he removed the food and only played the metronome. The dogs began to salivate in response to the metronome alone. Pavlov concluded that if a new stimulus was present when the dog was given food, then that stimulus became associated with food and caused salivation on its own. When he published his findings, Pavlov called the food an unconditioned stimulus because its effects on the dog were not learned. Instead, they triggered an unconditioned response that happened naturally and completely out of the dog's control. The metronome is at first a neutral stimulus. Through the process of repetitive pairing with food, the dog learns to connect the two. This means that the neutral stimulus becomes the conditioned stimulus, and the response to that, a conditioned response. He also reported that 1. Learning occurred most rapidly when the interval between the sound and the appearance of the food was short. 2. The saliva produced by the sound differed in composition from that produced by the food, which means that the conditioned response was not an exact replica of the unconditioned response. 3. While there are several forms of conditioning, such as forward and backward conditioning, classical conditioning cannot create new behavior or be used for training, but instead triggers involuntary biological responses. 4. We can almost entirely undo the conditioning. This happens through extinction when we repeatedly present the conditioned stimulus in the absence of the unconditioned stimulus. So, what occurs inside the brain? When a dog sees the food, the signals from the eyes and nose stimulate the brain, which activates the salivation glands to secrete saliva to aid the dog with the digestion. When a dog hears a sound, the ears send a signal to the brain, which takes note but has no reason to activate anything. When the two different neurological processes are being activated simultaneously, new synaptic connections occur between the auditory stimulus and the behavioral response. Over time, these synapses are strengthened so that it only takes the sound to activate the pathway leading to salivation. You can try this popular classroom exercise. Take a friend, sit down and relax for 2 minutes. Then allow your partner to check and record your pulse rate. Your partner will then tap a pencil on the desk 5 times. Right after, stand up and hop on one leg for 30 seconds and then check your pulse again. Repeat the procedure 4 times, having the partner record all data. After relaxing for the 5th time, your partner will tap the pencil 5 times as usual. Now, instead of getting up for your exercise, only check your pulse. If the conditioning was successful, your pulse rate will rise even without engaging in exercise. What do you think? Does classical conditioning always work? If so, are commercials a form of mental manipulation, and should we limit advertising in public spaces?
Operant conditioning is based on the idea that we can increase or decrease a certain behavior by adding a consequence. For example, if a dog poops on a carpet, we can either provide reinforcement so the dog does it again, or punishment so the dog stops. Both reinforcement and punishment can either be positive or negative, which means we have 4 possible ways to teach this dog a lesson. We can draw the 4 options in a table. If reinforcement is positive, we add something pleasant, like a cookie, to increase the likelihood of a behavior. If reinforcement is negative, we still want to increase the desired behavior, this time by removing something unpleasant, like the leash. If punishment is positive, we add an unpleasant response to decrease behavior. When punishment is negative, we also want to decrease behavior, now by removing something pleasant, like the comfy carpet. If we stop any sort of manipulation, the conditioned behavior will eventually disappear again. This is called extinction. Operant conditioning was first studied by Edward L. Thorndike and later made famous by the work of B.F. Skinner. Skinner believed that organisms are doing what they do naturally until they accidentally encounter a stimulus that creates conditioning, which results in a change in behavior. To test this, he placed a rat inside an operant conditioning chamber, which later became known as the Skinner box. Among other things, inside the box was a lever that would release food when pressed. Conditioning happens in a 3-term contingency, today known as the ABCs of behavior. A stands for antecedent. The rat accidentally hits the lever that triggers the release of food. B stands for behavior and refers to the response. The rat keeps pressing the lever. C stands for consequence. Food keeps coming out. The strength of the response to the conditioning depends on the schedule of reinforcement. If there is always food after pressing, the rat behaves predictably. If the food is released randomly, the rat behaves erratically like an addict. Skinner, born in 1904, was a professor of psychology and subscribed to behaviorism. He argued that you can only study behavior that is visible, and anything happening only within the mind is either a misconception or irrelevant to science. He thought free will was an illusion because behavior is either random or a reaction to the environment. His work became the foundation for behavioral therapy, military drills, and animal training. You can try this classroom exercise on positive reinforcement. One individual must exit the room. Now decide on a task which that individual will complete, such as finding a particular book. Then, choose a non-verbal way of reinforcing that task, such as clapping your hands. Invite the person to come back into the room, and let them try and complete the task, but don't give any instructions. Every time they are on the right track in regards to completing the task, clap your hands louder. If they move away from performing the task, reduce your applause or stop it entirely. Once the person understands what they are supposed to do, let them explain the task. Did they get it right?
Now, you should be able to answer these questions. Why you feel excited, sad, anxious, and depressed after any losing trade. Through classical conditioning theory. Also, you should be able to answer the question why you cannot control yourself from entering new trades using operant conditioning theory. Let me explain more using a more sensible example. Casinos and lottery ticket businesses running their business using operant conditioning theory. Because they give people random rewards, people keep playing and playing. Sometimes it could lead to erratic behavior and what we call pathological gambling. If you as a trader doesn't have a strategy to trade in markets, then you only have 50% chance to become successful in any trade. What happened to you is like coin flipping. In each try, you have 50% chance to close the trade with either profit or loss. If you are doing trades without any predefined strategy, you can make money every now and then, which leads to opening trades after trades without having control over your behavior. As it was mentioned in operant classical conditioning, exactly like the rats in the Skinner's box. Rats didn't receive food anytime they pushed the handle. They started behaving erratically, and they become addicted to pushing the handle of the feeder machine. Most traders become addicted to trading very soon and they cannot control their behavior. Unfortunately, they don't even notice what happened to them. After defining the roots of the problem in trading, in next video I will try to talk about techniques that help traders breaking the vicious cycle of uncontrolled trading. At the end, I would like to thank Sprouts for their great cartoons and artworks. You can support them using their Patreon at patreon.com/sprouts. Thank you for watching this video. You can follow me and support my work using links below, my Telegram channel, my PayPal, and using patreon.com/snipertraderstocks.